This video series highlights how the Desmos graphing calculator can be used to help students check for or find answers on the EQAO Grade 9 math test. Note that a familiarity with Desmos graphing calculator is helpful, but these videos might help with that. And for some questions, students will still need to have a basic understanding of the expectations of Grade 9 to be able to use Desmos effectively. However, Desmos is a great tool that I feel I underused in my classroom. We're going to review 4 areas where Desmos can help: graphing, tables, algebra, and number sense. Let's start with the most obvious one, and graphing. So I've created this little mock test that's got a bunch of different practice questions that we're going to go through in this video series on how Desmos can be used effectively. So the first and most obvious one is a question like this, where we have equations and we need to match it up with a graph. Now, to help, first, one of the most important computer features that you'd want your kids to be able to do is to split screen. So I'm going to just do split screen on mine, depending on your device or the Chromebook or whatever your students are using. You want to make sure they have this tool, because having the question and an open tab like this in Desmos or Polypad or anything else is going to be really valuable. So we've got the question right there. I'm going to type in 8x minus 3y equals 24, and already I have an answer that looks very, very similar. Of course, you'll want to dive in a little deeper. You can zoom in to get the graph scales to look the same. You can click on numbers to see that that's 3 and that looks like 3. Move up and down, that's at -8. And so it appears that I'm going to select the first one as the correct answer. But a great multiple choice or strategy for solving multiple choice is to check other ones. So I'm going to still just check the other question, and you can see this one doesn't line up exactly at 3, so I'm going to eliminate that. Notice that you can turn on and off graphs so things don't get confusing. I'm going to leave that first one on because that's the one I think it is. But again, this is great because in minutes, or seconds really, a student can check and see that answers are right, but also ones that are not, so they have full confidence in it. And this one, of course, goes through 3, not goes through -8, so I don't think it's that one. And finally, I can even copy and paste this to make this a little quicker. And -24, again, that's obviously not the one I want, and so I feel really good that the answer I have is correct. All right, let's look at another one. One thing we'll notice too is as a student is going through this, they might have stuff already on the on Desmos, so they can either just quickly X out of that or simply open a new Desmos screen so that they have everything fresh. That's up to them as they're managing this. I'll just clear that out. So in this second question, you'll see that, of course, we would have to have our students know a little bit about writing this as an equation to be able to use Desmos effectively. But I think y equals mx plus b is probably one thing that a lot of our students are good at. So if we can put in y equals -4 over 5x, notice that, of course, if I put the x here, it's in the wrong spot. So teach the students to move their cursor over so the x is outside, and a y-intercept of 6. You'll see that from my previous question, I'm a little bit off kilter, so putting the home button gets us back to find something pretty quick. And again, using these features here to see what that spot is. So that's 6, and it appears this is 6, and going through, well, sorry, this one goes through 7.5. So it looks like A is 7.5. This one, I can eliminate these two because neither of those go through 6. So it's just a matter of which one goes through 7.5. And it looks like A does work. So I'm going to choose that one. For this, I'm going to open up a new screen. So I'll open up a new Desmos screen. And of course, this is a question that when I first was doing it with my students, I would show them the algebraic way to solve this problem, which still is great. Sub in x and y and find out whether the answer is less than or equal to. But using Desmos is a great way to check this work or even maybe solve it. So there's the region, or the inequality is defined by that. And then we can just start putting in the coordinates. So -1, 2. And right away I can see that -1, 2 is not in that region. 4, 0 I'm going to predict is. 2, 4. And the students might be able to just see it to be able to predict some of these right away. 2, 4 is not. -1, 4, or -4 looks like it is, but again, it's just seconds away to confirm my suspicions that it is these two. And so the black one was this one, so I'm going to say that that one is correct, and these. And so graphing is the most obvious and best way to quickly use Desmos. In future videos, we'll look at tables, algebra, and number sense. Thanks for watching. We'll continue our video series on how the Desmos graphing calculator on EQ can be best used on EQAO Grade 9 Math. In earlier video, we looked at graphing questions. Now we're going to look at how we can use the table features of Desmos effectively. So I'm going to dive straight into one of our questions in our mock test here, and looking at this question, trying to figure out which one of these is linear. So I know our math teachers will be able to look at it, and of course our awesome grade 9 math students can see that C looks like the one that has the same first differences, so we can probably go here. But let's use Desmos to see if we can confirm this. So again, the split screen is key. So I have Desmos open over here, and I'm going to add, so I go to the plus, and this time I'm going to add a table. And we'll add in our first example. So we're just going to go 1, 2, 3 and type in the numbers for A, which are 1, 3, and 6. And immediately you can see, and we'll zoom here, that this is not going to be straight. So I feel pretty good about that one. Even though we're pretty confident C, let's just quickly check B. And again, that one looks like it's off. Now let's go to the one that I feel good about, 2, 5, and 8. This one does look like it's in a straight line, but I will check D as well, 4 and 8, and again that does look a little bit off. So that's great, but it's still, I'm not 100% sure that it's C. And this is where a newly released feature of Desmos is really powerful. So I'm going to go to my answer of 2, 5, and 8, and I'm going to check out with using a linear regressions. Now, linear regressions used to be a little bit of a pain on Desmos, but they've simplified this significantly by adding this button right here. And so if we, with one button, does a linear regression, and now you can see that all of those go through that point really easily. So now I feel really confident that this is the linear one. I could go back and check some of those other ones, especially ones that were kind of close, and you see that it does a linear regression, but because these are not in a straight line, the linear regression isn't quite perfect. And so that's a quick way to check. Just while I'm here looking at linear regressions, it even gives you the equation of the linear one. So if this question wasn't just about which one is linear, but asked you to find the equation of the line that goes through these points, one button with a linear regression, and you have your answer. Let's look at another one. So this question talks about a table showing the relationship between the distance of an object traveled over time. And we want to know, continue this table to see what's the distance traveled in 5 seconds. So We can clear this off and add a new table, but for the sake of time, I've already added this table in for us. So there's the table 0, 0, 1, 1, 5, 1.5, 2, 3, 3, and 4.5. So looking here, and we can see that that is pretty straight. As expected, this was a linear. I'm going to go and push the linear regression button to just go off and get what the regression on this one is. And so I want to know at 5 seconds. So one quick way you can do it when you're on the line, you can take your cursor and go right to 5. Now it's a little bit of a pain, especially if you're using a trackpad, but it looks like my answer is 5 and 7.5. There's one way to get my answer of 7.5. Another is to actually go in and put these in. So I'm going to put 5 seconds. So I'm just going to put it at the end of my table, 5, and let's try 6. And you see that it now screws up the linear regression and it doesn't appear to be in that one that we want. Go back and put in 6.5. Again, this doesn't look like the right one because it should go following in a straight line. Go in and put in 7, and even at, I know 7 is not one of my answers, but you can see 7 isn't quite perfect, so 7.5, however, does get us right on there. And then 9, again, is off. So whether you use the linear regression or not, and I'll just delete it, you can get some pretty confident answers that yes, indeed, that does match. If we do use the linear regression, you would have the equation, and you can also check by substituting in 5 into this equation, and even just doing this 1.5 times 5, and we get our answer of 7.5 really quickly. So all ways we can use this table to answer this question. Let's look at another one. So this might seem like a similar one, and in fact it is. But I wanted to bring this up because we're going to have to change our scales to be able to see what's going on. So in this question here, we're talking about emptying a pool. And so now the numbers are in the 60s and 55,000s. And so when I input that, we have some problems. Now I'm just going to make this a little bigger so you can see all the features. So there it is. But again, when I look at it, it doesn't appear to be what's going on. So I'm going to go to the settings. So the graph setting is up here, and this is where you can change this. Now you can scroll in and out using your trackpad, but of course this is pretty far, so the settings feature is better. I've got some X's going from 0, so I'm going to go 0 to maybe 60, and so you can go to your stuff there. And again, the Y's, I'm going to go from 0 to, 0 to 60,000. This gets us a better idea. From here, I usually zoom in and out just to get a better picture, because when you put it at 0, of course, it's right up along the edge. So there I have got a pretty good idea of my graph. And so now I'm going to use my linear regression button. And again, this will now just allow us to continue on, and I can zoom out and pretty quickly see that the answer is 120. Again, because of the awesome features of Desmos, I can just click on that button and see that 120 is when I'll have 0. And so if I go back to my split screen and pull up my answer, there we had 120 minutes was the answer that I am going to pick. This last question sort of combines my earlier video on using graphing and tables here to effectively answer this question. So this one says information about two linear relations is given. What point satisfies both? So again, we would hope that the student understands in order to be part of both, if we were to graph these, we'd be looking at the spot where the point that is on both the graph and the table. So I've already copied the graph into this starter spot. So let's put in the equation, y equals negative 2x plus 11. Now you notice, of course, we'll have to change my view a little bit so I can see all the points on the table. But the table, of course, just has this. We can quickly use the linear regression button to get a line that goes through those, and then to spot where they must satisfy both pops up immediately as 1, 9. So we can suspect that that line becomes 1, 9. You, of course, can check the other ones. So 0, 0, 0, 0 would be down here. It doesn't look like it's on either of those. 0, 11, 0, 11 looks like it's on the black line, but not in the table. 5, 25, so 5, 25 is around here, and it looks like it would be on the table, but not the graph, but 1, 9 is. You can, of course, sub things in here. So if we wanted to actually put it in here, we would see that that dot would line up with that line. As I tested other ones, remember the line would change, so we don't necessarily want to trust that. But if I had this out, remember I do get the linear regression, so I can actually write that equation down. Now, if I turn off the table, I've just got this blue one. Let's make it purple. This purple one that represents the table and the black one. And now I can do a test of any point. So let's test that point 1, 9. And I can see it's definitely on that. But if I wanted to test something like 0, 11, you can see it's not on this purple one. I think the 5, 25 is on the old one, so it would be part of this table, but not part of the line. So a cool way to quickly get a check that the answer is 1, 9. All right, so there's 4 ways that you can use tables and to answer EQAO type questions. Let's move to some ways you may not have thought of using Desmos on EQAO grade 9 math test. In previous videos, we showed you how to use graphing and tables. Now let's look at ways you can use algebra. So we'll dive right in and look at this first question. Which value of x makes this expression true? So again, we hope that our students can solve this algebraically, but Desmos is a great spot to check that our algebra is correct. So again, I'm going to go split screen here, and I'm going to put the equation 5x minus 1 equals 3x plus 9. And you'll notice that when you put in an equation, because there's only one value for x that is true, you get this line. And that is the value for x. And you can quickly see, just by pushing this, that the answer is 5. So all equations, because there's only one value for x, are going to produce this vertical x equals line. And we can even just confirm it by just going x equals 5. And you'll see that this green line just goes over top of it. So x is, in fact, 5. So very quickly you can put an equation, and get your answer right away. Let's look at another question. This time we're looking at equivalency. Here's an expression 4x minus 8, and we want to see which one of these it works. So I'm just going to delete those, and I put in the first one, 4x minus 8. So 4x minus 8 is our goal. That's our target. So if I go underneath here and I try the other equations, 2 bracket 2x minus 8, I'll get a different graph. The only way this can be equivalent is if it produces the same graph. And so obviously that's not going to be one of my answers. So I'm going to turn that guy off. 5x minus bracket x plus 8. And notice that this one overlaps the graph. So I feel confident that this answer equals 4x minus 8. And so again, this is, I can check the algebra and of course see that it's minus x minus 8, so that does work. But Desmos is a great tool to check that answer. This is a question that select all, so we're going to have to try all of them, not just find 2. This third one, 2 bracket 2x plus 4, overlaps, so it looks like I'm going to select this one as an answer. And then the final one, 4x minus 3 minus x, well, it should be a 3x, so yeah. You see that's pretty close, but of course doesn't match. And so very quickly, Desmos will allow us to find the 2 that does work and check our algebra. Here's another one where it's a drag and drop in Desmos. So I've got the main one out there, so this is our target. But notice that, of course, when we graph this is going to produce a graph we really don't look at a lot of in grade 9. It produces a quadratic. Now, students should be familiar with this as a non-linear one, but they don't know anything really about quadratics. But again, we're just trying to make this match. So I've got an option of choosing like a 4x squared, and let's put a 0. So I'm just going to go and see if that works. 4x squared plus 7x is in there, and then minus 0. And I can see, just choosing a different color. By the way, if you change colors, you click and hold. That's how you get that menu to be able to change. So I can see that that one doesn't line up, so this match doesn't work. Let's just quickly change the second one. If I change this to a 10, that doesn't work. If I change it to a 5, that doesn't work. And that's because my first one of 4x probably isn't right. Let's try 12x squared. And again, a little bit of algebra will tell me that I've got a 3x times a 12x is, 3x times 4x is 12x squared. So I feel better that this one works. And look, indeed, 12x squared plus 7x minus 5 ends up being exactly the same as the one we had there. So I feel good that that's my answer. In some questions, you'll have examples like this, where the expression is given to you with y's. So just a little heads up for your students, if you were to graph this, go y9, it doesn't really help out because it's explicitly in terms of x. So you'll want to teach your students that let's use x instead of y, and then still use our things. Again, this is a graph that is very different than what they've seen in the past, but we can now go in and go x to the power of 4 times, remember times is the star button, and in Desmos it appears as a dot instead of the x, y to the power of 5, again, using x, not y, and I can see that those two do line up. And so I'm going to feel confident that this is the answer I want. I can quickly check other ones. You can either type them, you can duplicate them, you can go here and duplicate a bunch if you want, or you can copy and paste. I'm going to try x to the power of 5, x to the power of 4, and, oh, sorry, this one's plus, isn't it? And just turn that guy off, and you see that that does not equal, so this second one isn't going to equal. This one is x to the power of 9 times x to the power of 1. I already know that that's 10, so again, that's not going to equal. And the last one, I'm just going to delete this and do x to the power of 10, and highlight it and go divide or use the slash, x to the power of 1, and I can see that that does map over top, so I feel good that it's going to go there. So again, educating your students that you don't always have to type in these numbers here. If we're going to Desmos, we can translate it to x, but still be able to check our answers. Of course, you know in the exponent laws, it makes this job a lot quicker, but Desmos is a tool you can check your work. And finally, since we're kind of solving equations, why not solve the one that we are almost guaranteed to see on Desmos, and that's the Pythagorean theorem, or more commonly known as the Pythagorean theorem, the side length relationship for right triangles. And so again, students will need to understand which side's the hypotenuse and how this works, and they could do it on their regular calculator, but know that you can also add it in here. So if we did a squared, let's say that's 4, so I'm going to go 4 squared plus b squared, it looks like 13 squared, equals, now if I go c squared, that doesn't really help us again because we're using c, but if we use x, then if we look back, we'll actually see a graph of this function with 2 answers. And that math teachers will know that this is because it's a quadratic, there are 2 answers, but we only want the real one answer. which is right there, and it looks like 13.6 would be the answer. Anywhere on here is gonna, that's gonna be 13.6. Anywhere on here is 13.6. The other one, of course, is negative, but doesn't make sense in this real life example. And so we can see, though, that 13.6 is my answer. And if I had a different one where, a different question where I was doing this and I had the hypotenuse, let's say is 15, again, I'm not going to use A, I'm going to use X, but it does get my answer right away by using this. So just a little bit of education that when we're using Pythagoras, we'll get two answers. We want to find the one answer that works. So there's a couple of ways that you can use Desmos and algebra to help with your EQAO math questions. Our final video in this series of ways you can use the Desmos graphing calculator on EQAO Grade 9 math test is about how students can evaluate. Now remember, Desmos at its heart is a calculator, and so we can use the features of the Desmos calculator as you would a normal calculator. Now note, a regular handheld scientific calculator may be better for students than the stuff I'll show you here. But remember, Desmos is not just a graphing, but it also has a scientific calculator. So I'll show you those. So in our first question, we've got a fraction one. Let's see how Desmos handles this. So I'll split screen this. So I can put the expression in here. Now, it's a little dicey putting in a mixed fraction, because if I try and go 2/1/4, you'll see that I get 21/4. So if I try and get out there, you know, it's a little bit harder. So the little cheat for this is to type in the fraction part first, move your cursor to the front, and put in 2. I'm going to zoom in here because we're going to be using less of the calculator part and more of just the entry. So I've got 2/1/4. Times, of course, is the star button. And now let's put in the second mixed fraction. I'm going to start by putting in the 2/5 part and move my cursor in front and get 3. So the answer tells me is 7.65. Now if I click on this button, it gets me a fraction right away. So now the question is, which of these answers is that? Well, immediately I can eliminate this because the denominator is not the same, but I wonder if it's these other ones. Which one is it? So again, if you know how to mix fractions, you can do this on your own, but let's just put in the answer. So I'm going to put in the 13/20 and put a 6 in front of it. Right away, it just doesn't evaluate for me, so I'm going to check by pushing the fraction button, and you see that these fractions are not the same, so we don't have that right answer. So now I'm going to try the 7 instead. So I go to the 7, and I see that they're equivalent fractions, and that's my answer. Now remember, I also had a decimal answer, so if I click this back, I'll get that decimal answer, and I click this. You can copy that mixed fraction, put it down here, and it will get you a decimal answer. But the feature of having them as fractions allows you to make that comparison pretty quickly. So I feel confident that that's my answer. Again, a great strategy with everything is to check the other ones. So I'm just going to check 6 and 2/20s, and that's not the same. And even though I'm pretty confident this one is not, I will check that it is indeed not the same. And so I can use this like a calculator. But I am going to show you and remind you that Desmos has its own scientific calculator. So up in the URL, we see we go to desmos.com/calculator. If I just go and erase the calculator part and just go to desmos.com, it takes me right here, and I can choose all the different types of calculators that we have there. So I'll use the scientific calculator now to answer this question. And here you can see the fraction button is embedded in the work. So if I type in 2 and then I want to do a fraction, I can just go and put that in, 1/4. I get that. I can go times, of course it replaces it with the dot, 3, and then fraction 2/5. I do get the answer, the decimal answer, but if I want that mixed fraction, it's there. I push enter, and just like a large screen graphing or scientific calculator, you can keep stuff there. So I'm going to double check my answer of 7 and then the fraction 13/20. Push this button and see that it is indeed the same number. If I just push enter, I can get another one and check my other ones. So there's the Desmos scientific calculator. And of course, you can do it on the handheld calculator, something the students might be more comfortable with using to also do some of these features. Let's move on to another question. Scientific notation. So first we'll do this on a Desmos calculator, or the graphing calculator. So 1.2 times 10 to the power of 4. And you'll notice that it does tell me right away the answer is 12,000. And so that's great. So this is a great spot to use scientific notation. The scientific calculator, of course, will do it as well, times 10 to the power of 4. And you can get the answer right away. Now, there is some limitations because we don't always have room. So if I think I can go up to 8 and it will tell me this, but as soon as I get to 9, it just spits out another answer. Even if I make this bigger, I still can't get any better than that. So there are some limitations on using the Desmos as a scientific calculator. You can also go down to -4. When you're using the graphing calculator, you can get down to -6. When you're using the scientific calculator, if I put in -4, again, it's not quite, it shows me the scientific one, but it does go down as small as -3. Similarly, if you were going the other way, where you had the number here and you had different Desmos, or sorry, different scientific answers, it doesn't go the other way and put it in scientific. But what you would do is simply put in the answers and check to see if it matches the question. So that's how we would answer that. Here's another one where we got scientific notation, or sorry, scientific notation, and we need to put it in lowest to greatest. So if I just go straight to the graphing calculator, I've got them all inputted here, and they've converted them all to decimal and real number form. And so I can quickly see that the biggest is 360, or 3.6 times 10 to the power of 5. The next biggest, it looks like this, so I'm going to move that guy down here. And it looks like my smallest is there. So again, very quickly I'm able to do that with the limitations that not every scientific one goes off like that. One last little cheat code I'll show you when you are asked to try and move things or rank things from smallest to largest. When you have these numbers, a little cheat is to turn these into points. So if I turn each of these onto points, then they'll appear on a number line. So you can see that we have these now being points on a number line, just making all of the y coordinates 0. So you see, of course, these numbers are really big and small, so it's hard to tell which is bigger or smaller. But if I zoom in, I can see that the blue dot is slightly smaller than the red dot. So I know that this value is smaller than the red. And then I'm going to have to go out pretty big, so I'm going to have to change my x-axis to like 5, 5, 5, 5, 5, 5. And here is one of my black dots is here, and the other one, the purple, is way down here, so obviously the black one is much larger than the purple one. So this feature is a cool little feature. When you're asked to arrange things in order, you can kind of use the cheat code of like what is bigger, 4/7 or 0.5. You can see the decimal is there, or you can put them as coordinates. Oops. And that will tell me that the green one is further on the number line, so it must be larger. So that would be the final way that we can use Desmos as a way to support students in EQAO math. Please check out the other earlier videos on how I also used Desmos to show how to do graphing questions, tables, and algebras. Thanks for watching and good luck.